Good morning, everyone. Today is May 9th, 2020, and this is the John Chappell Natural Philosophy Society Science Chat, and I am your host, Franklin Hu. And today, let's see who we've got here. Today, we've got Dennis Allen and Bill Lucas and James Keene and Ian Cohen. So, all the usual suspects. Welcome, guys. How are things going?
Not too bad, thank you. The weather's lovely here.
Yeah, we've already gotten all the way into May, right?
Anybody have any snow?
Let's see. You're a little bit quiet there, Bill. How things where you are, Jade?
Everything pretty good. I think I'm getting over my headaches, which were, I think, from the Kung Fu virus, which is great because this has lasted on for weeks and weeks. Now, I just wanted to add, while I'm speaking, that in the private chat, I put up a link to my new video on inertial propulsion mechanism, and it's based upon a new paper on my website journal, and I mentioned that because last week's presentation on inertial propulsion, there were a few corrections that had to be made, and so this video is sort of an update. By the way, shout out to Dennis. Dennis Allen is mentioned by name at the beginning of this video for his contribution to my thinking on the subject. Yes, there he, thank you, Franklin. He put up the link for the video.
Okay, excellent. Okay, so if anyone wants to do that, you'll have to make sure to put in the secret password at the end there. GZXQ0LTQ9. You expect people to type that in there and not make a mistake? No.
Well, actually, why don't you just go to BitChute and go to my channel, which is Binary Mechanics Lab, where the spaces in that are underscore characters and the first word is capitalized. I say that because I think the searches on BitChute are case sensitive. So you just look up Binary Mechanics Lab, and that would be the latest video posted. Thank you, Franklin, for that clarification.
On your main website. Okay, well, if you guys don't have any particular topics you want to talk about, I thought I'd do something called mailbag here. Let's see here. Let's stop this. So mailbag is we're just gonna go down and answer my science email here, right? So I thought that might be interesting. So you guys feel free to chime in if we hit upon any topics that are near and dear to your heart, okay? So I'm going to share my screen. And if I bring up a personal email you weren't supposed to see, well, ignore it. Okay. Let's see here. It says Chrome has a bug that can cause screen sharing to crash in Windows 10. And that is exactly what was happening to me before. So
again, we can't see anything, Franklin.
You can't hear me?
No, we can't see your screen. If
oh, yeah, you can't, because last time I tried to do this, I shared my screen and then I completely crashed the system. So I need to bring up a different browser. You guys been seeing any emails recently that you wanted to discuss? Well, I'm trying to bring up Firefox here. Currently, there's some discussions going around about mission theory, and there's another theory about what is propagating the waves in space. And what else are we arguing about? Couple different subjects going on in the email these days here. So let's see if my Firefox is going to come up here. let's see here. Let's sign into my mail. Okay, let's see. I think that seems to have happened.
Maybe we all can sing a song, to fill in the dead space while Franklin is working on the technology.
Yeah, anyone got a good song?
Sing Kumbaya.
So, Bill, are you working on any projects? Are you going to get that book out soon?
I just
Let's see. We can
Can't
hardly
hear
hear
you.
you, Bill.
on coral rings.
Can't hear you.
Seen
You're very, very low.
rings just like tree rings, except that there's a ripple in it, and it shows how many days.
Apparently, Bill can't hear us.
Was that so?
Perhaps not.
Yeah. Can't hear you, Bill. Can't hear you.
Oh, okay. Well,
Yeah, there's some problem with your microphone there.
can you hear me now?
A bit better.
Just barely. Speak louder. Turn up your mic.
Well, I have two. I had that one as high as it would go, but is this any better?
Well, it's
A little bit.
It's just about audible. Yes.
Yeah. Anyway, I was going to say I was doing work on coral, and the limestone coral has rings like tree rings, but the difference is, besides having a ring for each year, it shows how many days were in that year by a ripple. And so if you look at the oldest coral, you find that there used to be 486 days per year, and now there's only 365. And so that means that the Earth has expanded due to the decay of gravity. And so I've been able to predict that decay. And I've also shown from the data that has been measured, there were 2 times in the history of the world when the decay rate and the number of days per year kind of oscillated. And one was at the time of the um, uh, Noah's flood, and the other was at the time when Joshua was leading the children of Israel, and they had a long day during which the Pacific Ocean was created. And so those 2 times you can see the evidence for it on the actual number of days per year, those years. And so anyway, it's a very interesting topic. And I noticed that a lot of the papers on it have been removed from the internet because they're not politically correct. So in other words, the people who are running the scientific community do not like you to know that there's evidence for these things. And the evidence was taken by NOAA, and so it was under contract. And I have some of the papers that I've downloaded from the internet are not there anymore. They're all taken down, and they were official papers by people publishing with NOAA, and they're no longer available. And so anyway, it's interesting. We see the same thing going on there that we see in other fields of science that we work in, and I think it's symptomatic of the present day. So
You're
anyway,
being censored, Bill, huh?
yeah. So anyway, everyone who has a theory of the nature of the universe, needs to be able to explain why gravity decays. And we have many types of evidence for the decay of gravity. The expansion of the Earth is one of those, and we have the U.S. Navy took what are called sonar logs and hired a contractor to take the sonar logs from all the ships from the time of World War One to the present, and to make a plot of the bottom of the oceans. And the plot of the bottom of the ocean shows the stretch marks for the expansion of the Earth. And so that's very interesting to see that. And then if you look at the fundamental constants, the big G for gravity is only good to 3 significant figures. For the other constants, they're good to 8. And that's because it's changing all the time, and in its decay. So they don't want you to know what they measured it 100 years ago to be, because then you would realize what's happening. And so they don't want to admit it's decaying, because they don't have a theory that explains the decay of gravity. And the cosmic background radiation that we observe is actually due to the decay of gravity. And it can be predicted from a proper theory of gravity. So you have many kinds of data that can be predicted from the decay of gravity. And those things just are not being paid any attention to in the scientific community. And if you submit a paper to a politically correct journal, they'll have to refuse it. If you go to an alternative science journal, you can publish it there, but not in a like a AAA.
To what do you attribute the decay in the strength of the gravitational field?
Well, the gravitational field is due to the average force between the neutral electric multipoles in atoms or even elementary particles. So, for instance, if I have atoms and they consist of protons in the nucleus and electrons outside, then each of the protons vibrates with respect to an electron. And the vibration could be a dipole, or it could have a quadrupole, or even an octupole vibration. And those vibrations, if you calculate the net force between, let's say, 2 atoms, you find that it's proportional to the number of multipoles that are in the atom, and the distance of oscillation. And so it turns out that it's a very small fraction of the distance between the electron and the proton, about 1%. And but that, and a lot of that, if you have spherical symmetry and all that, it's in the atom. A lot of the terms cancel out, but some of them don't. And that's why the force of gravity is 10 to the minus 40th power as strong as the Coulomb force. But you can actually calculate it, and then you can see what it is, and you can even measure the change in the mass of one atom by changing the state of some of the electrons, so they're no longer participating in a neutral electric multipole. And I just read an article on the internet where they started to measure that, and they can actually measure the change in the mass of an atom, one atom, using certain devices that they have that you measure very critical small things. and they were able to show that an atom changes its mass when you just take one electron out of the atom. It changes the mass slightly, and you can measure what that is. And if you put one electron in an excited state, you can see the change in the mass too. They just put it in an excited state. So there's a lot of interesting things that are coming about, and I've been publishing papers on the electrodynamic theory of gravity, and the advantage of that work is that if gravity is electrodynamic in origin, the electrodynamic force is the universal force, and NIST has already measured the properties of all the nuclear isotopes to 8 significant figures, and now there is no longer any data to support the strong interaction force or the weak interaction force. But they don't want you to know that, so they put on their website, they put the values that they measured for all the nuclear isotopes in a certain order, such that you have to, by hand, copy them down into your computer in the order you want to see them, and then you can make an analysis of it. And I did that. And there's about 3,500 nuclear isotopes that have been measured to 8 significant figures.
Yeah, so Bill, your volume is still coming in very little. I'm not quite sure if there's, yeah, it's like your internal microphone is turned down or something. But those settings are usually pretty hard to find.
Yeah, well, I'm sorry. I just did an update on this computer, and it probably changed some drivers for some of the audio.
Yeah, it probably did. Probably in the sound options, there's probably microphone level, and it's probably turned itself down. That's what happens during updates. It's like it just resets everything back to some unusable level, and it's not easy to find. But in any case, now unfortunately, I cannot share my screen at all. If I attempt to do so in Chrome, it just crashes me and takes me out of the system. And if I go into Firefox and I try and just log in as a regular user, it doesn't let me do that either. So I can't share my screen at all without crashing out. So I guess I can't really do that. I suppose I could just go over the emails and just read them to you anyway, since the only thing you would have been able to do differently would be to read along with it. Read along, but maybe we're just going to muddle along that way anyway. You're not going to be able to, I'm not going to be able to share my screen. I'm getting a little bit of echo here, so who's echoing? Okay, let's try that. No, it's still echoing. Let's see, is that Bill? The only one who's got open mic. Okay, so that fixed that. I guess you had a little echo there, Bill. So let's go into the mailbag here and see what's in the mailbag here. So what's up here? So we have a discussion here about basically what is in space that is carrying the electromagnetic waves. So one of the hypotheses is that it's actually the like hydrogen and helium that's in the space, which is actually carrying that actually serves as the medium for the waves. So in the comment we have here from here is that it's unlikely that that you reckon that in the vast void between the galactic clusters, it's teeming with enough protons to carry the full range of electromagnetic radiation from radio wavelength to gamma wavelengths from distances of 14 billion years. And he says, sorry, I find this ridiculous. anyone else wants to comment? So personally, I mean, this is the problem with using the like hydrogen or helium as the medium for electromagnetic waves, is that there just isn't enough of them. And that if I would think that if the medium was that you would see a significant change in behavior when we have like, you know, a compressed, you know, a lot of like hydrogen and helium. You think that would change like the speed of light significantly and so forth. So I personally don't think that the intergalactic medium serves as the medium for wave. So what do you guys think? Could that sparse hydrogen and helium between the galaxies be allowing us to see the starlight because that's what it's actually traveling through? What do you think, Ian? Up or down, right?
Can you hear me now?
Well, if I may comment, one of the consequences of what I call full quantization of space, time, and energy, is that all questions of this category become moot. You know, like in terms of what is it, like for example, in the light speed derivation paper, which is a recent paper on my site, it's one state quanta, which are injected in one side of the simulated space and detected exiting the other side, and that's what the light signal is. So, you know, when you decide to take the step of full quantization, all of these questions about, well, what is it, are out the window. They're quanta, period. There isn't anything else except one state quanta. And these can form particles and protons, neutrons. Here, I see Dr. Lucas has his hand up, so I'll be quiet.
Can you hear me any better now?
Oh no, that's even worse, I think.
No, still the same?
Nope, still can't hear you there.
Okay.
Looks like there's a problem with your headphone, potentially.
And you can't hear any better now, or can you?
Still can barely hear you.
I don't know, maybe.
Try it without your headphones and get closer to your computer, I guess.
Yeah.
Wherever your microphone is on your computer.
It's in my screen. So let me see if I can get a little closer.
I have a very primitive setup. It's just a laptop. I'm using the laptop camera and the laptop mic.
Yeah.
And
I would
the
suggest
sound is coming
that
out the
your headphones
speakers,
unplugged.
but the sound is so low that it can feed back into the mic. So perhaps you ought to get rid of all those headphones and stuff and just use what's on the laptop.
Yeah, well,
Yeah, make sure that your headphone, wherever that's plugged into, unplug it so that it'll start using
I'm not
your
using
laptop.
the headphone. It's completely unplugged. But
But in your discussion a couple of minutes ago, it wasn't too bad. So if you could go back to that, it's still too low.
Yeah, what you were doing before was better than that.
And especially in a technical discussion, if you lose one or two words in a sentence, you sort of can lose track of the whole meaning of what you're saying. So it's important to have a proper volume there, buddy.
yeah, unfortunately, I got a new piece of software and it updated all my audio on my computer. And so what I can do is use another computer. I'll log out and come back in on another computer. So you can talk until
Well, could I just say in the meantime then, just maybe fairly quickly, that I think all attempts to accept an ether, but to equate it to a rarefied gas, have really resulted in failure. I mean, you can go the other way. You can sort of evacuate, a flask more and more and more, make it into almost a perfect vacuum, and you don't really get a variation in the speed of light. So the ether, if you like to postulate it, seems to be more tenuous than any sort of atomic elements or mixtures thereof. It goes down to maybe some finer grained elements. I have an open mind on all these. I don't actually postulate what the ether is. I just measure its properties, and then I maybe theoretically look at how it behaves. But I do think that it's very, very difficult to advance arguments that the ether is equivalent to a gas, such as rarefied hydrogen and helium.
Yeah, that's kind of one of the points, is that if we can create fairly good vacuums here on Earth, such that we know for a fact that there's only one atom per cubic centimeter or something like that. So few atoms that it just seems, while you can't rule it out technically, there's so few atoms in there that you can't really see how that could, for example, propagate a gigahertz wave, right? I mean, that's just too much motion and too little things to propagate that. And now the argument being put forward by the proponents of this is that there's no such thing as a vacuum, that no matter how hard you try in any experimental setup, you can never actually get to a true vacuum, right? It's just like, no matter how hard you try, you can't get to absolute zero. So that's their argument, and that they are basically, although it's kind of hard to hear to figure it out because they're not going to answer our questions, but basically the way they wiggle their way around that is by saying that the atoms actually change in size. There's this argument that if you have a pool of mercury, that you'll see that the mercury atoms will rise up, and you can detect them even though they're surrounded by oxygen and nitrogen atoms, which are all much lighter, right? So the thinking there is that the atoms actually kind of change size. They're saying I challenged them about, okay, well then your atom there can grow infinitely. So even though it only takes up there's only one atom per cubic centimeter, that atom takes up the entire cubic centimeter, right? Thus producing a completely solid medium is kind of what they're thinking there, right? Although my counter argument to that is that we do have empirical measurements of how big these atoms are, and they're in the angstroms range, which is very small, and we don't have any evidence that they expand out like that. So I'm not terribly convinced that the medium is this rarefied gas. So I personally think that, contrary to what James is saying, that I believe that that there are in fact particles, right? So I don't particularly think that that even if the world is actually some sort of simulation, that the simulation on a computer, that the computer has to support the concept of particles, right? And that in order to support the mechanics of waves, that the waves themselves still have to be some sort of conglomeration of those particles in a compression rarefication kind of thing, right? So I would disagree with James that the actual waves are inherent in like his bit streams. His bit streams, I would agree, could create those particles like electrons and protons. That I can put my head around. But for higher level, and I would say this is a higher level phenomenon, wave phenomenon. So wave phenomenon builds upon particle phenomenon, right? So in some ways you can say that the wave is kind of built on whatever the particles is, but that's not really a direct consequence. So Is that right, James? Because James, you were kind of implying that when we see electromagnetic wave, like a radio wave, and we can slow those things down, you can like see a 60 hertz radio wave on the oscilloscope. Is that a direct action of your bits going in there, or is that just kind of an indirect action because your bits form electrons but there's still this question of what is propagating the actual wave. So the two hypotheses I'm trying to separate out here is your hypothesis, which is the wave is actually just, it's like implemented on the metal, right? Okay. When you see the wave, the peak go by, it is somehow directly related to one of your bits going through your system. Versus my hypothesis, which is that the space is filled with particles like electrons, and what we're seeing when we see the height of the wave is that we're actually seeing a compression. That's all it is. That is, we're seeing a compression of those particles, right? And it's not really a direct consequence of the underlying mechanism, right? So, what do you think, James?
Well, see, Al, I don't know really how to interpret what you're saying. If we quantize space-time and energy, the one state bit, which I call a quanta, is the basic element or item of energy, and everything else comes from that. Now, in what you're saying, Franklin, there are two vital things missing. One is the system state. You have to mathematically define, and you can do so in binary mechanics, what this system state is. And then when you're talking about, well, how does this wave do this or that? You need time development laws. Once you have defined a system state adequately, and in binary mechanics, unlike quantum mechanics, the system state represents both momentum and position at the same time. In quantum mechanics, you can only represent one or the other at one particular time. Once you have an adequate definition of your system state, you need the proper time development laws. Apply those laws, and then you've got your universe, okay? So all of these questions about how this or that happens, well, it's the time development laws, of which there are 4 what I call bit operations in binary mechanics. So getting back to the original question about from 5 or 10 minutes ago, of, what is it, in terms of the ether or the particles or this, that, or the other. Well, we don't have to worry about that particular question anymore, because whatever it is,
have to worry about that.
It's one state quanta. One state quanta can aggregate and form particles. One state quanta can be transmitting or by application of the time development laws, moving from a source to a destination. Detectors, as in my light speed derivation experiments. So it's definitely a radical approach. I'm not pretending that it's all that normal and everyday thing, because all of the continuum math is thrown out the window. The continuum math mostly comes from statistics, in terms of extracting eigenvalues and this, that, and the other. I'm not sure whether the statisticians stole that from the mathematicians, or the physicists stole it from the statisticians. But basically, the particle physics math, in terms of extracting eigenvalues and eigenstates for allowable energies, is the same math. Excuse me. But getting back to the question again, unless you define your system state and say, oh, okay, binary mechanics, here's the math of how Keen defines it. My math is different, and it is this. And then once you have a system state, that's just one point in time. You need then the time development laws. And in what Franklin has said thus far, neither the system state has been defined or the time development laws of how that system state would change over time. And so, I mean, it's sort of unanswerable. It's sort of like more, how are all these words of particles and the wave goes from here to there, and I mean, what does all that mean?
Well, let me see if I
Until
can,
we can operationally.
here, okay?
Yes, go ahead.
I claim that that's all false, okay? That you're getting into physics, which is mostly, I don't know, more mathematical than I would say intuitive, because there are various ways of thinking about things. I think probably physics has probably got a little bit overboard with mathematical description. So I'm going to present an alternative world that doesn't require any of that. None of this time development stuff, none of this bit operators or stuff like that.
And I would suggest is that it's undefinable what you're saying.
And I would claim
it's
that
undefinable.
I would say that is absolutely false. And I would say that the reason why it's false is because we live in a physics world, and we think of things in physical terms of things which actually exist, right? So we have, physical things, they move around, we can observe them, right? So that is actually the only thing that we really know. Well, all we really know is that in the world we have these objects, they slam into each other, they make noise. This is what we can truly observe. So this doesn't look like a computer or anything. So all we know is that, we have these hard objects in the world, right? So that doesn't require any time development, nothing about bits. It's just an observation about.
Well, wait a minute. I just saw your hands move when you bang the two objects together that went click, click, click when you bang them. I just saw your hands move, man.
Yes, you did. So that has nothing to do with time development or any of these requirements. It's just physical.
That's what time development means. Things change over time. The position of your hands changed over time.
Okay, well, that's obvious.
That's what time development means.
So we just know what that means.
I mean, just to help us, define the terms.
Time is any time when you can detect any change in the state, right? From moment to moment, if you can see that state has changed, like you go from here to there, that if you see my hand actually changing state on the screen, that is time, right? Right. So we can agree that that's time. And I can even agree that time is quantized, that if you were to look at it at the very, very finest level, you would see that my hand actually doesn't move smoothly, that it actually jerks. Right? I can't move my hand completely smoothly. And if you were to look at it on your computer screen, you would see that that's actually a fact, that even though it looks smooth, that it is actually moving a pixel at a time, right? There's no in-between pixels. So
it sounds like you're advocating binary mechanics
no,
without the mathematical formalism.
Okay, just a second, James. Let me speak. I let you speak. So I am saying that what you need to start with, though, is the realization that there are particles in the world, right? Now, I don't necessarily know what the particles are made of. I don't necessarily know what these two Lego bricks are made of. Whatever. But we do know what their properties are. So they can't go through each other, right? And you hit them, they make noises. They probably have a resonant property. We know all those things, right? And in order to answer this particular question, which is what is an electromagnetic wave, right? I'm claiming that we cannot just say that we can ignore that question. That causes extreme violence in my mind. That you would say that we don't need to know what a wave is. We can just explain it away as some aspect.
I haven't said that.
Binary mechanics.
I have never said that under any circumstance.
That's what we're trying to explore.
So that's not a quote from me. I've never said that.
Again, Dave, please let me talk, okay? Let's put the rule that while I'm talking, don't interrupt me, okay? When I stop talking, at least at the end of the sentence, then you can talk. Otherwise, we're never going to get anywhere here, okay? All right, so I'm saying that you need to start with the particles themselves, right? So if you have particles themselves, then you can sensibly demonstrate what that wave is. So like in water or air, we can demonstrate that it is actually the air molecules, which are just like those are bumping into each other. That, when I clap my hands, that creates a pressure that's causing a sudden increase in pressure, and that is what's traveling out, and then it hits my eardrum and it causes an impression upon my eardrum from literally all the particles hitting my ear. And that's how we accept how a sound wave works, right? I would not say that it doesn't matter. If I were to ask the same question about, well, what is a sound wave? And you told me that, oh, this doesn't matter. This is all just a property of binary mechanics. I would say that that's wrong, because what we do know, I mean, this is settled science, that we have the oxygen and nitrogen molecules in here that are running around, and it is the impression of those molecules which is creating, the perception of sound. So to say that none of that matters is what I'm saying is wrong. Okay, so your turn.
Well, I don't know where you're getting these quotes. I've never said any of those things that you attribute to me saying. So I don't have any response.
No, I am saying
whoever
that,
says those,
you're saying, but the question is, what causes?
they should respond. Or perhaps you're creating, what do they call it, a paper tagger? You're fighting against somebody that's not even here. Because
Well, that's
I
what
certainly
we
don't say those things.
So how do you respond to that? How do you respond to, how does the sound wave works? Does it require a medium? Is that a good question?
Well, in binary mechanics, I've demonstrated that even perfect vacuum is a volume filled with it's literally teeming with one state quanta. And obviously, in such a case as perfect vacuum, if we want to really be technically strictly correct, there are no atoms. However, quanta can aggregate, I call it baryogenesis, and so do other people, into like protons and neutrons and so forth. And that's, by the way, one of the big forces in gravity, our effects in gravity, which is completely ignored. How quanta aggregate into these particles, and that certainly sounds like gravity to me. But getting back to what Franklin is saying, I think the only reaction I have is that it sort of sounds like the way the ancients would approach physics. Yeah, no, like I don't know, that I have these two objects, I click them together, the air vibrates, it gets to my ears, and well, fine, but what does this have to do with advancing physics now?
Well, I would say it has to do with that, because I believe that the sound wave mechanism and the electromagnetic mechanism are in fact the same mechanism. Now, the only problem with that is that there doesn't seem to be any medium in like the vacuum of space that's like the air molecules in the air. I mean, that's a big problem. You won't find any science saying that if you take a bell jar and you empty out all the air and you shine a light through it, clearly there's something propagating it. It's not the air. That's what we were discussing earlier. It's not the air that's propagating, that's allowing, say, the laser beam to go through the bell jar. There's got to be something there. So I would claim that there is things there. There's like a neutron sea or something. There is some sea of matter there that we
well certainly whatever is there.
I agree. Whether
anything there or not, as you know, it has electrical and magnetic properties, and that facilitates the transmission of the electromagnetic wave.
Yeah, we know.
The gross
That's a big
matter in
question.
the case of sound has compression and stress properties.
Yeah, that's the $23,000 question. It's like, what is that thing? That was the whole point of the email thread. Somebody is claiming that it's literally the air. Okay, I claim it's not, right? I claim that if it was the air, then if you pump all the air out of the bell jar, then it should at least be harder for the light to go through. But apparently it doesn't. So there must be, if there is a medium, there must be another medium, and I think it's important. Yeah, I think there must be another.
Well, actually, Franklin and I appear to be in some rather great agreement. I'm sorry if I interrupted, Franklin. I'll try to stop interrupting. But in my recent paper, and I think I even presented some of the slides about it here on this site a month or so ago, in the paper that you can find called Vacuum Composition, I debunked the idea that perfect vacuum is empty space. No, in fact, it's teeming with one-state quanta. Just amazing. So that when Franklin says, yeah, there must be something, when I pump out the glass jar and shine a light through it in this perfect vacuum, the light goes right on through. There must be something in there carrying the signal. Well, I'm saying, yes, I agree with you, Franklin. There is something in there because that perfect vacuum is not empty space. I've debunked that in my mind, at least. And it is full of energy quanta. And if there are certain thresholds, if the concentration, if you will, of energy quanta is enough, they'll tend to assemble into protons. And so then you won't have.
I disagree with
which is going to give you hydrogen. So really, in a way, Franklin's way of thinking that he's been presenting is not really in contradiction with my work, if you will.
Depends on what
it's not that I want to go ahead. Excuse me.
See, now it kind of depends on what you call our one-state quanta. I mean, we can all agree that there is something in space, and that thing is not air. It's not atomic matter as we know it. It's something else. So James says it's one-state quanta, and I would say it's electrons. Actually, electrons and positrons, or neutrons, I guess. I've been more going towards the thing that fills space as being a neutron, since neutrons clearly exist. Okay, so and it's not clear that positrons and electrons can exist in pairs, right? So it would be, I'm feeling it to my advantage to use the neutron as the example as the space filling thing. So my neutron, though, is not a one-bit quanta, right? It's not that at all. So at the very
no, it's not, and that wouldn't be perfect vacuum either, because where you have neutrons, they're going to decay into protons and electrons rather quickly.
Yes, so, I mean,
it's called beta decay. And
yes, okay, I'm glad you brought that up.
And so if you say that my media is neutrons, well, not for long it is. I mean, it's going to be hydrogen gas.
Oh, not true, not true. Now, neutrons within atomic matter last forever, right? Neutrons in atomic matter do not decay, not unless they are in a, I don't know, radioactive element. But neutrons within, say, oxygen, normal oxygen, last forever. So why can't my neutron
I would contest that.
last forever as well?
No. Sorry. Read my paper on weak force boondoggle. Protons and neutrons are changing identity all the time within multi-Z atom nucleus like helium, nitrogen, oxygen, on up. So in other words, every time a neutron emits an electron to become a proton, we don't necessarily have to assume that electron leaves the atom and is detected by some sensor we have out here in the lab. That electron can be absorbed by a neighboring proton within the nucleus, and so that which elements of the nucleus are neutrons or protons is a very labile thing. It's changing all the time. It's like musical chairs. With beta decay, what we're detecting is those few electrons which actually find their way out of the nucleus. Otherwise, they're switching. Who's the proton and who's the neutron? That's switching all the time, at least according to my work, which of course can be accepted or rejected. I've got a whole paper on it. It's quite simple and straightforward, actually, if you look at what I presented.
Okay, well, that's a
Weak
different
force boondoggle is the title.
That's kind of a different theory. I mean, what's that debate here is if space is filled with, say, neutrons, then how come we just don't see that whole thing just decaying in 15 minutes, which is what it would do, right? The whole space should disappear. Half of it should disappear in 15 minutes, right? If space were filled with neutrons. But my claim is that, well, first you have to understand why neutrons decay. It's, like I said, my point is that clearly neutrons don't always decay. Now, I said they were stable, but you said that, well, they're not exactly stable, but they're but they don't. So you're saying that the neutrons, even within the atoms, are not stable, but they're just being reabsorbed, right? Which I suppose is a possibility.
Well, a boatload of experimental observations indicate that they're not stable. As a matter of fact, measuring beta decay near nuclear reactors and so forth is a routine thing. It's because the neutrons are not stable. So this idea, this model that you set forth of a volume full of neutrons, well, those would, from everything we know, decay into protons and electrons. Well, what's that? That's a hydrogen gas.
Yeah, so I have to
And
argue
it's not perfect vacuum anymore, and we're trying to explain perfect vacuum.
So I'm trying to justify why
On the other
neutrons
hand,
are stable in space. And I would say that the evidence is that neutrons can be stable inside of atomic nuclei, so they're not inherently unstable. So it's a matter of the environment. And so my claim is, my hypothesis is that the things that we see as neutrons, so these are the things that come out of atomic fission reactions. Those things are high-speed neutrons. And actually, the only reason why we see them decay is because they actually impact another neutron in space. So you have all these neutrons out in space. Then you have this high-speed neutron, which is coming out of the atomic reaction. And those two, when they slam together in exactly the right way, they join together. And those two things have the same components as a proton and an electron. Because in my hypothesis, the neutron is just a positron and an electron, right? And so you've got two positrons and so you've got positron, electron. You put them together. Now you've got two protons.
So you're contradicting everything that we know about neutrons in physics.
Well, the thing is, we don't actually know that much about
positron and electron.
I'm not contradicting.
There's nobody.
Anything. See, I'm explaining.
There's nobody who thinks that a neutron is a positron and an electron.
That's right. That's
one
my hypothesis.
Researcher, mainstream.
Well, if you look at mainstream,
at least you should preface what you're saying.
No, this is true.
You're the only one on earth who is saying this. There's not even a single other person that you've convinced of your point of view. Not even one,
right? Because no one's got really understood what this thing really is. Now they have done careful atomic studies to determine what is the charge density distribution within a neutron, and it's not zero. There's like an inside positive core and then an outside negative shell. It would appear, so that even a neutron appears to be made out of charges, right? So that's direct support that a neutron is some sort of positron and electron. That is empirical evidence that you can see, right? And they can see proton has got like three little things. That's why they think proton.
But it convinced nobody. There's not a single person, even a far out extremist, what do they call it?
But that's not a scientific argument at all.
radical scientists, such as we have here.
That's how all
that-
theories work.
Everyone else believes that the neutron is a combination of a proton and an electron, and that
Yes,
it
and that is
decays into a
incorrect.
proton and electron.
See, that I'm saying that's incorrect. I'm also saying that quark theory is incorrect as well. I mean, but that's not an argument. See,
So
as a
at least
scientific argument goes,
you're saying that you're alone in your hypothesis. That's okay. That's fine.
that's okay. That's perfectly
It
fine.
could be you're the only one, or
At some point, the guy
but you're
who's
right and everyone else is wrong.
okay. We're going to have to stop talking over each other. I don't know how we're going to do that.
If I could just come in quickly there, just getting back to the ether. I mean, I'm quite agnostic in regard to the ether, and in fact, I would even go further. Like both of you have made some hypotheses, and perhaps there's some truth in either or both of them, but they are rather speculative. Now, the ancients conceived of all these elements as being quite distinct, like earth, air, water, ether. And as we advanced in science, we sort of integrated these. We said, well, the different states of matter. You have liquid and you have solid, but they're really the same. They're atomic, and so on. However, we may have gone too far. I mean, I could conceive of the ether as being a different state of matter or existence, or whatever you want to call it. In other words, our current atomic theory might not be capable of explaining the ether. Now, I know you have your own ways of doing it, both Franklin and James, and you've looked at these things. James is the quanta business in binary mechanics, and Franklin has the positron electron system and so on, and they may very well be true. But for my part, I just have such an open mind, or I believe that the system hasn't been clarified yet. The jury is still out. I have such an open mind on this matter that I could conceive, going back to the ancients, of the ether as being a different sort of existence, a different sort. I don't even know if you call it matter. A different sort of entity from our ordinary atomic matter, and therefore trying to describe it in terms of that could be fraught with difficulties. And maybe that's one reason why up to now we haven't succeeded in doing it.
Well, certainly that is, among dissidents, the popular solution, which is to invent a different particle that represents space, call it fundamental particles. Someone uses FP or whatever. And and that is supposedly something which is very, very different than the recognized particles, right? So, so James's 1-bit quanta, I would say, is perhaps a little bit like that, although that's supposed to be implemented in a computer. But a lot of people would create, something like a circulon or whatever on is what is normally done. And we've seen some. I think Alistair, you have your intertwining balls together. That's another example of the ether existing as some other particle. So, but that's kind of why I tend to get away from that, because I always call those things like, little green fairies. You can invent whatever you want, but it is in fact an invention. And unfortunately, whatever you've invented, there's no experiment you can run to actually detect it, because if it's not regular atomic matter, which is really the only thing we can detect, then there's no hope for detecting that thing, right? There's no experiment you can run to detect the 1-bit quanta. I mean, you can't do it. It exists outside of what is experimentally available, right? There's just no hope. So anyone who has an experiment like that has no hope of experimental confirmation. At most you could say it's consistent with existing experiments, but if someone were to ask you, can you actually find me that particle and show it to me and put it in my hand? The answer would be no, if it's not ordinary atomic matter. So that's why my hypothesis.
Can I respond to that?
Sure, go ahead.
Can I respond briefly to that, sir?
Go ahead.
I haven't worked out the quantitative details yet, but I think our electron detectors that go click, and scintillation counters and things like that, are detecting single quanta. That's what they're detecting. Each click is one quanta.
Yes, of course they're detecting one quanta, but we're not detecting, say, the direct evidence of your bit, right? Your bit exists in a computer, right?
Well, what you wanted to do is to see some phenomena that results from one quanta.
No,
and I
that's
just
not
cited
enough,
one.
because certainly we have all of quantum physics to
Cited.
prove that. Right, we have all of quantum physics to prove that there's quanta. I mean, there's electrons, we have spectra, which quantized. There's all kinds of stuff which is quantized. So
Not quantized the way I've done full quantization.
yeah, you would
There
have
is
to
not.
find something which is, I don't know, but still, you can't find your one bit quanta. There's no experiment, there's no experimental setup that could, you can't stick your one bit quanta in my hand at all. Not like I can stick Lego bricks in my hand. But if space is made out of actual ordinary atomic matter, then you could do that. You could say, there it is, I've got a handful of it. So if it's neutrons, then I could say that. I mean, experimentally, we can find the neutron and we can show that it's actually there and it actually exists. And, the other experiments I call out to show that this is true is that, when we do pair production, we can tear positrons and electrons out of bare space, right? Vacuum. Suddenly, two positrons, electrons pop out of space, they go flying in opposite directions, right? So how does that happen? So logically, they were probably there before, right? Because you're looking for some kind of medium which is really hard to detect, right? So if it's a neutron, neutrons are probably the hardest things to detect. In fact, we can only detect them by their decay. If they never decayed, we would have no means of detecting them, right? Because the only way we can detect the neutron is there is if we see the proton electron pop out, right? That's how we know a neutron is there. If you have a neutron goes through a cloud chamber, it does nothing. It leaves no tracks, nothing. All neutral particles leave 0 tracks in any of our detectors. So if you did have a sea of neutrons, I would claim that none of our existing experimental instrumentation could detect it if it didn't decay. And I would say that the reason why neutrons decay is due to their speed. So the neutrons that we can see are always positron-electron pairs, which are moving at relative velocity to the background. So I would claim this is one specific experiment you could do. If you had something generates neutrons, say you're gathering neutrons off this nuclear reaction, and you slowed them down. Now we can do that. These are called like thermal neutrons. And I would claim that if you slowed them down the whole way to 0 miles per hour, that I would claim that they would just literally vanish, right? They wouldn't decay. They would just meld back into the background and they would never decay. And I think this is actually one of the reasons why there's currently this anomaly about neutron decay, and that the half-life is not precisely known. That depending on how you do the experiment, they're getting longer lifetimes for neutrons when they really should all be the same, right? But I'm thinking that depending how you do it, you will lose some neutrons to them being absorbed into space. And that would give like an infinite half-life to some neutrons, and that would throw off the whole half-life measurement for everybody.
Yeah, Franklin, may I just draw your attention to a couple of posts by Alistair? I don't understand them, something about slitting throats or something, but he's put a link up to some paper concerned with gravitational waves and maybe ripples ostensibly linked to the Big Bang. I'm not quite sure. I think he wants to speak about it anyway.
Okay, let's put Alistair on here. There you go, Alistair.
Woohoo! The slit the throat thing, that was my vote when we went thumbs up or thumbs down. My microphone was not on, so I cast my vote by saying I throat slit that idea. That was my vote for thumbs down. That's all. So
Okay, so you don't believe that air is the medium for the electromagnetic wave?
that was a long time ago.
Yes.
May I have my turn? Because you went on to a bit of a diatribe there about the musts that you concluded based on the existence of a medium or not. And I'd like to say, you said we cannot show you a whatever it might be we feel the fundamental unit may be. And so I wanted to say, but we can see its reflection in things. If it has a non-arbitrary suggested shape, then the existence of reflections of that shape within natural existence are evidence of its existence at the lower scale because they are reflections of it, mathematically predictable reflections. There's no reason why that's not valid. And so I posted that link, which is to an article from 20 years ago, which talks about the cosmic microwave background. And there it is, the shape I suggest as being the universal particle.
Yes, that's true. We've heard that argument. So I would counter.
I can't show it to you. And I say, there it is, shown to you 20 years ago.
And I would counter that with the argument that basically, if I look in the clouds, I can see flying pigs. I can see pretty much anything. And in the gamut of the world that you see there, lots of things have the same shape. Like we're looking at the COVID and they're all exponential curves, and exponential things are very, very, very common. And in particular, with the kind of shape that you're looking at is very common with a wave phenomenon.
Is it? You've
like
seen
that.
Lots of other places, have you?
Yeah, I mean that's I think that's fairly common. I mean, you've found several places and things would look just like your what do you call your particle?
Universal building block.
Universal building block. Yes, that looked like your universal building block. Although I would say that that is not a valid argument to say that at the microscopic level that something like that exists. There could be lots of other reasons.
I didn't say that it was, but you said specifically, if there's a what's it at the microscopic level, you can't show it to me. And I said, well, yes, I can.
And I would say the reflection is not a valid way of showing that, because you're not showing me the particle. If you show me the CMBR, we're looking at the CMBR, not your particle, right?
You're saying the map is not the territory.
Math is certainly not the territory. Math.
I said map.
The map does not represent your basic building block.
I'm saying it does. My point was that perhaps it can be shown. You're saying it can't be shown.
Yeah, and I'm saying that does not show it. That the CMBR looks like your building block, that does not show your particle exists. That shows perhaps there's some.
My particle does exist, and it does show it, because there it is. Show it.
It absolutely does not.
Well, sure, but I'm not saying that it's proof. I'm saying it shows the ability to show it.
No, I don't even think that shows the ability to show it.
Huh.
What
I
shows
guess
the
we're gonna
ability
have
to
to
show
agree to
it
disagree.
is that you have to run an experiment, you have to isolate it,
It's
perhaps make like Bill has, that the things that we recognize as actual particles, you can build a beam out of them, right? So
okay. Here, follow this. If we detect something in the infrared, we can't see it because our eyeballs don't see infrared, but we know it's validly representing reality, true or false, because we can detect it persistently, reliably, precisely with equipment. So you can't call infrared spectrum, not real. It's real. The CMB has been specifically, precisely, persistently, consistently measured and shown to have that specific shape. That's not making a pig in the cloud in the sky. That's
yes, but this is a
specifically
different kind of
measured.
phenomenon which we are familiar with because infrared radiation is known as a class of electromagnetic radiation, and we have specific sensors which can be used to detect that phenomenon. So definitely we know what that is, we know how to detect it. Now this is different from your fundamental building block where we don't know what it is and it can't be detected.
Oh, in that same article, it goes ahead and mentions that if you were to hit a regular perfect sphere with two off phase gravity waves, that wave would result. So, for example, if you had an electron in space and you nailed it with two halves of a gravity wave, like off two offset waves, then that's the shape the electron would adopt. That is a gravity wave shaped sphere, is exactly what it is. Now, you can go ahead and disbelieve that it exists, disbelieve that it's even a possibility, totally claim I'm wrong, but don't say that it can't be shown, because I'm saying it can, right there and there. Bam.
Well, I need you to present an experiment, and you can pretend you have all the money in the world and access to every experimental apparatus possible. You can use the LHC if you want to, but what experiment can you propose that would, I don't know, show an actual picture of your fundamental building block? Like we show it in a scanning tunneling microscopy picture. If you could show me something that looks exactly like your fundamental building block, then that would count as actual detection.
If you take a Higgs boson and split it in half, you get a universal building block.
Okay, well then I guess so. But that still doesn't. I mean, really, if you take a Higgs boson, you split it in half, you get a positron electron. That's what LHC is looking for.
Yeah, okay, that may be. I don't know.
I mean that.
No, you can't get electron and positron. Okay, left and a right. Sure. Okay, I agree.
I mean that's what it look. That still doesn't show that you can't build a beam out of your fundamental building blocks.
You're looking for electron positron, so that's two bipoles. The universal building block is a quad pole. You have two quad poles. You have two averaged out. They average out to being the same thing. A electron positron. You make up, like, if you make up magic charge is one thing, but I'm talking about physically, inherently, visibly built right into its structural integrity. It is a quad pole, and two quad poles will produce the effect, after you add motion, of being a pair of bipoles, a positron and a electron.
then why not just call your fundamental building block a neutron then?
Didn't want to.
Because that's all I'm doing. Because, you know, I have no really big problem with your fundamental building block, but I think what that thing really is what we currently call a neutron. That's just the simplest.
It's a quadpole. It's the cavitation maker. It's what makes electrons pulsate. I mean, makes atoms pulsate. It's the cause of everything, up and down, left and right. It's not a neutron. It's a quadtron, if anything.
A quadtron.
But that's an awkward name for it.
That's very awkward.
And it implies that maybe bitrons exist or something like that. I don't want to throw that implication out there with my name, so I call it universal building block because it's kind of self-explanatory.
Well, I mean that's where I have that problem. As a scientist, you know, I have to be able to relate it to what else that we actually know exists. So we actually know that positrons and neutrons and protons, we know those things all exist. So if you're trying to make a space-filling medium, I need to know what's that made of? You know, like as Ian suggested, you know, maybe it's not those things at all, right? Maybe it's some other thing, right? Like your fundamental building block, maybe it's that, right? But I prefer not to do that. I think God made the universe with as few pieces as possible. And so I'm going to use the pieces I've got. I've got protons, neutrons, electrons, and positrons. Those are the 4 building blocks that I have. So if I were to pick any of those pieces to make a medium out of, you know, if I picked all electrons, let's just say I make an electron C, that was Dirac's postulate. Then we'd have this massive negative charge everywhere. I think we could detect that. Or we could make everything out of protons. Now, proton is just hydrogen, right? So that's saying that all space is made out of hydrogen gas. That's clearly not the case. So we can't use all electrons. We can't use all protons. We could use all positrons, but then we'd have the same problems that we do with electrons. So that leaves neutrons, okay? If we use the neutron, then we would have properties that the space would be extremely hard to detect because it doesn't react with any of the charged matter that's us. It would not show up in any of our detectors, but yet it would be omnipresent. It would be also extremely dense. And this is the other argument against the atmosphere being the thing. Because we know that wave propagation is kind of proportional to density. So the denser object like steel will propagate things like sound waves faster than air, and it goes generally with the density. So it's whatever the propagation medium is, it has to be extremely dense. And so a neutron C would be extremely dense. People who have done calculation of this is similar like the Epola calculations. Like 5 million times denser than steel. So this is why light travels so quickly through the medium, because it has to be extremely dense, yet completely invisible. But still, you can relate it to the particles we see, like positrons and electrons, because you would predict that if space is filled with these neutrons, and neutrons are made out of positrons, electrons, that you could eject them from bare space. And in fact, we can. That's exactly what we see. You put enough energy in, you can get them to eject, right? And that you would also predict that if the neutron was actually a positron electron together, you know, we would predict that from chemistry, basically, that the binding energy would come out during the reaction, right? And that's what we see. We see E equals mc squared. That is the binding energy that comes out.
I have a question.
Chemistry. So all those things are verified. So now, while you know your fundamental building block theory hypothesis could be perfectly correct, if I'm trying to choose between various hypotheses, right? And I would pick the one that's more related to the things that we know about, the 4 possible pieces that we know are stable, right? Every other particle in the universe only lasts for a millisecond, pretty much. But everything else is stable, and it's a real question why the neutron lasts 15 minutes. I mean, that's forever in the subatomic realm, right? Why is it 15 minutes? And I'm saying it's 15 minutes because it takes that amount of time for the neutron to exactly hit like bullseye with another neutron that's sitting in space and react and fall apart. This is what we observe as beta decay. So that explains why is it that the neutron takes forever to decay. But there's also other things like they're saying that the beta decay may be sensitive to, say, the neutrino flow, and that then you have to explain what a neutrino is, right? Now, neutrinos definitely exist, right? So within like this neutron sea, then what the heck is a neutrino, right? So in my hypotheses, that is just a very, very short wave that's propagating through the neutron sea, kind of like a Newton's cradle where you just have the line of balls and they just directly hit each other, right? That is what I think is a neutrino. It's basically a form of light. So that's why neutrinos have not really registered with any mass, because they're not a mass. They're an energy phenomenon, like light. It's just a very, very short pulse wave through the sea of neutrons, I guess. So, but that's kind of like, why I'm making this argument that if you're going to come up with some medium, you have your choices. You can make up something, or you can try to relate it to the particles that we know of, and that's what I've been trying to do. Now, I do see we have been getting quite a bit of comments here, and so let's just go through some of these things here. So I'm not sure what some of these comments mean, but stars mostly emit high etheric energy, aka gravity, and not light. Well, definitely stars do emit both. And actually, I would say that gravity and light are actually the same phenomenon, that fundamentally gravity is an EM thing. So I guess I could kind of agree with that. Another one, light is created in the atmospheres. Now, I would have to completely disagree with that, because I can just look at a light bulb and I can see light being created. That's definitely not the atmosphere. How about this one? Shouldn't the Michelson-Morley experiment be tried in lots of other settings? Yeah, lots of people have suggested that maybe the MX experiment should be, say, performed in space, where we think it, say, might not be entrained, and then we might get some different results there. But even other people, Dayton Miller in particular, performed these MMX experiments high up in the mountain where he thought it would be the furthest away from entrainment, and he did apparently get some seasonal differences, right? So, the funny thing about the Michelson-Morley experiment, this is like an experiment which has like been done by like a grad student with crude experimental setup, and was only done for like 15 trials. So we believe all this stuff off of some really, really crude experiment. And if you look at the data, it is really, really crude. So I think they should just do the Michelson-Morley experiment in a better way, right? So we've got, so the entrained ether hypothesis hasn't been explicitly tried while moving. And that would be true. I mean, I would think that if you got to come with an extremely sensitive Michelson-Morley experiment, and you put it in your car and you drove 100 miles an hour, you might see a difference. Although the Fitzhugh did similar experiments using moving water, and that's kind of a way of taking your medium and moving it. And we did see that the light was in fact entrained inside of the moving water. So I consider that evidence for water moving. So, and if you got other guys have any other comments while we're going through this, let me know. Otherwise, I'm just
Well, it's just that there would be a difference in the magnitude of entrainment depending upon the mass or the gravitational effect. I mean, in other words, you could have almost perfect entrainment on the Earth, but if you were going in a motor car at a high speed, you might have very little entrainment. And in the case of the Fizeau experiment, you were intermediate. You had a drag factor, but there wasn't perfect entrainment. So I would maintain that in a car or a plane, even say, if you did an experiment, sort of a Michelson Morley type experiment, you would find that there wouldn't be entrainment with respect to the translation of the plane, through the atmosphere, the upper atmosphere. In other words, you can actually speak on a plane, and you can throw a ball and you get all the same effects as if you're stationary. But if you did a light experiment, you wouldn't. You'd be able to show up effectively the speed of the plane, because there wouldn't be perfect entrainment.
Yeah, that would kind of be the presumption that the ether's entrained with, say, the Earth, and not necessarily your room. So like the atmosphere of my room, perfectly stable, right? If I were to put a pinwheel in, it's register 0, right? But we still might be able to register the 24-hour rotation of the Earth if my room is moving through the ether, right? So there'd still be an ether wind running through my room because of the motion of the Earth. In fact, that's what the SIGNAC experiment detects, so that we can detect the 24-hour rotation of a stationary experiment sitting in the lab, right? Which would indicate that the air itself doesn't entrain the ether itself very well. Although we know that if we do put light through like a gigantic windstorm, it entrains it somewhat, just like water would entrain it, right? So it has some effect, but it's not really, it's like a very leaky bucket, right? Or the effect that a net might have through water. There is some resistance, but not very much. But I would think that, if you ran an MMX in a plane, you might see the same results that Fizeau saw, that you would see the motion of the plane. We do have some, there's a Haffey-Keating experiment, which is kind of controversial, but I think if that was done correctly, that you would see the speed of clocks changing due to whether you are moving with the Earth or against Earth, because they did definitely detect this east-west kind of differences.
Can I talk on this?
Sure.
See, because I do believe that the ether encapsulates it travels with, so like the Earth is in a fish tank of ether that is traveling with it, in a manner of speaking. And in that instance, also the sun is in its own fish tank. Evidence of the interaction between the fish tank and the larger fish tank will show up when the solar magnetic polarity reverses. It will cause impressions and depressions on the Earth gravitationally, and that has been shown to be happening, which may show ether drag by showing the relationship between gravity and magnetism and motion.
Well, that's certainly possible.
It's happening. It is already happening. It's 1.5 cycles in, and it's perfectly in sync with the sun. And I'm not aware of any current theory that would explain that, but ether theories do.
But you'd have to wait for, like, I don't know, a shifting of the poles or something, right?
Another 4 or 5 years, and the sun flips magnetically again. And so if Greenland exhibits the same pattern that it did the last time the sun flips, that's pretty dang conclusive that it happened, 11.7 years later, the same pattern happens. That would be unlikely for it to be coincidental. And if it happens a third time, another 11.5 years in the future, also, again, in synchronization.
Well, how does that support entrained ether? I mean, certainly I would not be surprised. There are lots of things that synchronize up with that sunspot cycle, and it would have nothing to do with ether. So what were you saying?
It would have to be confirmed. It would have to be investigated and confirmed, because it is possible that the magnetic polarity of the sun is affecting the equipment directly somehow in a way that they haven't accounted for because they weren't aware it's happening. Possibly, some kind of artifact from the granularity of their data or something, or maybe the equipment itself is two satellites that orbit the Earth. So maybe when the sun changes magnetic polarity, the atmosphere expands and causes the satellites to behave slightly differently or something. I don't know. All of that would have to get examined and ruled out before it would be considered conclusive. But currently it looks pretty darn good. But it's not conclusive from an experiment, even though it is actually two experiments, because the first pair of satellites came down, launched the second pair already. So
well, that kind of reminds me of another convincing experiment that, for example, if space is, for example, made out of neutrons, and we figured out a way to just accelerate neutrons, and that's very difficult because neutrons have no charge, so you can't accelerate them through conventional electric charges. But presuming we find some way to accelerate neutrons, then we could come up with like a drive, because then if you could use the material of vacuum space as the thing you're shoving out the back of your rocket, then you would no longer need chemical propellants. That you would effectively be what is currently called the EM drive, right? We have these things which you put electricity in, and they cause an impulse, right? So one possible mechanism that those impulses could work on is if you're accelerating the space medium itself and shoving it backwards, right? Because if you could do that, I mean, it's just ordinary mass, neutrons, ordinary mass. If you found a way to shove them back, then that would demonstrate that your particle must be there, right? To create the reaction forces, for example. So that would be another way for anyone who wants to prove that their ether particle exists. If you could use it for propulsion, that would be a great boon to mankind, and would help definitely support whatever your particle is. And presumably your particle has properties that allow it to be pumped, right? If it doesn't, then maybe you're out of luck, and maybe I'm out of luck because I don't know that there's anything you can use to pump a neutron, accelerate a neutron, other than bashing into it. Then that would be another way of proving whatever theory you have about your medium, right? You could use it for propulsion. So Richard also asked, the mechanics of propagation of gravity is also mysterious. Are they similar? Yeah, gravity and light have some very, very similar things. I mean, they're both 1 over r squared. They both have infinite distance. Really very identical in characteristics. They, apparently perhaps travel at the same speed. And I would say my answer to that, my hypothesis, is that gravity is actually an EM type wave. That fundamentally, gravity is actually due to an electrostatic charge. And electrostatic charges are due to the resonant frequencies of positrons and electrons. So fundamentally, gravity is a wave, right? It's just an interaction of the wave with neutral matter. That's it. So that would be my answer as to why gravity and electromagnetic phenomenon seem so closely tied, because I would say they are in fact the same thing, right? Let's see, what other comments he says? So Richard also says, definitely not a compressible medium with stiffness. The properties required of the medium are impossible to achieve with ordinary matter. Well, I don't know why you would say it's not a compressible medium with stiffness. Because if it is a wave, then you definitely need both of those things. You need compressibility and you need stiffness. And certainly if you're talking about ordinary sound waves, we certainly achieve that kind of thing with ordinary matter, but there's no matter that's stiff enough or dense enough to meet the, say, speed of light. Although other people who have investigated this idea that space is filled with a positron, electron, they do calculations about how compressible and how stiff and what the speed of sound would be through that medium. And they, from basically first principles and just knowing what how much energy is released when positron, electron come together to get the binding energy. Now they come up with the speed of sound through a positron, electron medium is in fact equal to the speed of light. So that would be another piece of evidence to show that it's possible that the medium is just a positron electron sea of some sort. You do the calculations, it comes out. Yeah, and here's the agreement that we need to go take our Michelson-Morley and do it in space, go out someplace and just kind of try and test the entrainment hypothesis to see that, because I guess if we did send a space probe out in space, on the Earth, we would not see the orbital motion of the Earth. But if we go and we put some satellite out so that it's basically not in orbital motion, or we actually orbit a satellite at, say, the opposite side of the Earth, that an experiment like that, perhaps we should see the orbital speed of the Earth, right? You just put a satellite at the opposite end of where Earth is, same orbit, you should be able to detect the full motion of a satellite around the sun. Versus on the Earth, you don't detect anything. So that would be a definite thumbs up for entrainment. But that is a practical way of doing it.
Go to the second sentence he has there. One might be a bit conspiratorial about it. Dr. Carl Zapfi entered into some correspondence with NASA, about 50 or 60 years ago, and he made some proposals about doing this. And initially, because he was actually quite a respected scientist, they corresponded with him. But eventually, they just ceased replying to his letters, and he couldn't get anywhere. Now, the conspiracy is that, well, they'd say, what's the point in going to the expense of doing such an experiment in outer space? Because the science is settled. We know exactly that there's no ether and that, it would give a null result and so on and so forth. So he says, I can't understand why it won't be done. Well, the establishment will not do it for that reason. And that was shown by their treatment of Dr. Zapfi.
Yeah, that's a comment here, which is that they don't do it because they're so convinced that it wouldn't make a difference, right? They're 100% convinced that they're going to see exactly the same result.
Well, that's what they say. Perhaps actually they have a niggling doubt that it might show up a difference, which could be very embarrassing for establishment views.
Now, my evil plan is that the Michelson-Morley experiment, that is actually found in many, many high sensitivity experiments for different reasons. So my feeling is that this experiment has been done, but it's been done on other experimental platforms, not specifically for this reason. But if you were to reanalyze the data, you would find out this exact thing, which is that satellites can detect their full orbital motion around the sun with using a Michelson-Morley experiment. Because I'm sure MMX has been set, or some form of it has been set into space in different space probes for doing various things. But I haven't done the research and haven't found one specifically, but I'm betting that would be our only hope, is to reanalyze some existing probe data to show that, yeah, we can detect the motion of the full orbital speed in MMX in satellite, right? So Ned's got a question to Richard.
Franklin?
Yeah, go ahead, Dennis.
That he's right. The reason they don't do experiments like Michelson Morley out in outer space is it might upset their apple cart. They're happy. They tell themselves, our theory is good enough. Look at all the things we can do with it. That's how they rationalize it themselves. But they don't actually say that. They say, well, this is settled science, which of course means that it's a current science. And so why upset the apple cart? Honesty is gone.
We need to upset the apple cart, because I would say to anyone who makes arguments like that, then I'd ask them, okay, what's gravity? Blank stares.
Well,
What's
it's
charge?
electrostatic.
Blank stares. You know, if you ask an honest physicist those questions, they really have to say, we don't know, right? And that is the reason why groups like us exist, and that's why we talk about gravity and magnetism and charge and atoms all the time, because these are a lot of the areas where honest physicists have to say, yeah, we don't know what gravity is. If you ask me how charge works, yeah, we have no idea how that really works. There's no settled science. That's certainly not an area of settled science. But all of these questions go back to, like, if you're trying to figure out gravity, which is how does that propagate from one place to the other, right? And the only way we can figure out that there's something can propagate from one place to the other is if there's some sort of medium between them, right? That gets back to what we're talking about, which is there's a medium. Maybe it's made out of fundamental particle. Maybe it's made out of something that we can't detect. Maybe it's made out of a neutron Z. That's what we're debating here.
Is my mic on?
Yeah, your mic is on. Go ahead, Alistair.
Sorry if I interrupted you. I didn't mean to. I thought my mic was off at the backstage part there. See, yes, because if the medium travels with the object to a degree, then the gravity waves you have to recognize are shaped and have always been heading our way. So, like, we see, you don't think of something as 10 billion years away only affecting us now. It may have been affecting us for 4 billion years, that little tiny prick from that one little tiny direction. And every star in the cosmic microwave background is light coming at us and gravity coming at us. But you can't think of it just as it's getting here now. 5 billion years ago, when the Earth was coming into shape, it was within the influence of the CMB. And for the entirety of the 5 billion years that it's been rotating, it has been being hit by all the little tiny pinpricks of light and gravity coming from the entirety of the sphere that is the night sky. So you have to remember that, yes, gravity waves are seemingly, like they travel, but remember they have always been arriving, as well as that they're always arriving. They have always been arriving and have always been influencing, and that's why the medium can travel with us and seem to be part of us, perhaps, and still be justifiably explainable using logic, I suggest. That was my say.
Yeah, I mean, I like what you're saying there. I mean, I take it a little bit further, is that when you go and you see that little prick of light from the star, that what you're seeing is actually the gravity.
Yes, agreed.
Exactly, the gravity and the light both come down exactly to the Earth, exactly that way. So that little prick, you can think that that's what the gravity source looks like as well.
Now, then I'd
both from the invisible gravity frequency and also the visible light frequency. So, and you see the gigantic sun, and that's why it has so much influence on us, because we can see, its gravitational influence is equivalent to the visible spectrum, pretty much.
I would agree with that, with this one caveat. You've seen gravitational lensing, correct? Like Einstein's cross?
Yeah.
Okay. So that means we're seeing the same object 4 times in the night sky, which means there are 3 locations in the night sky that are obscured from our view visually because of the nature of lensing and the way light interferes with itself. Gravity, however, permeates rather than it's not the exact same as light, but very similar, and arrives with light. But in the journey between there and here, the light may have scattered and reconstituted, whereas the gravity, it just came right here, plowing right through everything, because that's what gravity does, because it's a permeator, not a absorber and reflector. It's a permeator. So that would be my caveat on what you said. But other than that, yes, that was great.
Oh, well, I would even still disagree with that, because I think that the gravity and the EM wave are identical. So if you did have like Einstein's cross there, and if you were to measure the actual gravitational effects, it would be consistent with the optical effect, that the gravity would appear to come from 2 places, right?
That may be.
I don't want to make an exception for gravity as being.
I agree, that's a possibility. I just don't want to conclude that.
Okay. That's what I want. I want to kind of keep things as simple as possible, using as few moving parts as possible. So if gravity
stuff slips through the cracks, if we aren't exact about perceiving things, then what's the point, right? Like you can't cut too many corners if you want to look for the exact right answer.
We're looking for the exact right answer.
Otherwise, you're just going to find another one of the 24 approximately close answers.
But I'd always prefer to look at the analogies rather than to say these things are identical. I mean, you could say, Franklin mentioned earlier about sound, you could say that gravitational interaction, or say electromagnetic interaction, bears the same relationship to gravitational interaction as, say, acoustic interaction bears to electromagnetic radiation. It's sort of it's the same sort of phenomenon, but it's in a medium where the speed of transmission is very, very much less. I mean, I accept sort of you can look at in fact Dennis has this in his books, and people like Jeff Ememko get a sort of a Maxwell type equation array for gravity, based on gravity and co-gravity as the analogs of electricity and magnetism. But I subscribe to the very high speed of interaction, of gravitational interaction, and therefore I would say the lower speed of electromagnetic radiation in an ether with particular properties, making the speed lower, would be analogous to sound in a gaseous medium, operating the same sort of equations, the wave equation, but having a very much lower speed.
Okay, so you would say that because gravity travels instantaneously, that it couldn't be exactly the EM wave phenomenon. That's
well, not instantaneously. I might say 2 times 10 to the power of 10 times the speed of light. And I know you gave an argument some weeks ago as to why the Van Flanden's arguments might not be the last word, because of this thing going in all directions and rotating around. But no, I do subscribe to that. Yeah, it's for all intents and purposes instantaneously, but it's not an infinite speed as Newton thought.
All right. So Jim is saying that there's another experiment here, Birlett Hall, which may have detected the ether wind due to the Earth's rotation. Although detecting the Earth's rotation isn't tough. I think Signac does that pretty clearly.
Yeah, but this Brilliant Hall was an type experiment rather than a Sagnac type experiment. And what it did is it detected this spurious signal of 17 kilohertz or something, which they dismissed as spurious, as I say. But
Right.
Aspen did analysis some years later, and he found it came out to be 355 meters per second, which is the speed of rotation of the Earth at that point in Colorado, where the experiment was done. So, in other words, the difference here is it's not like a Michelson-Gale or a Sagnac type experiment detecting a spin. It's an MMX type experiment detecting spin.
Oh, okay. Well, that reminds me a little bit about the geocentrist arguments. That the funny thing about the CMBR experiments is that they put the Earth in fact, at the center of the universe, because they can see symmetries of the CMBR, and we appear to be in like dead center in the middle. They call it the axis of evil. That they can't explain. Why is it that the CMBR measurements seem to put us at like the center of the universe? And one reason why the MMXs don't work to detect motion of the orbital motion is because there isn't any. The Earth is the only thing that's actually still. So, and that's what it kind of appears like. From the experimental standpoint, if you just ignore everything else and just look what the experiments say, they say that the Earth is a stationary spinning ball. That's what all the experiments, that's what all GPS has to actually use as a model, that the Earth itself is not moving except for 24-hour rotation. It has no translational motion at all. That's what the at least Earth-based experiments say.
Well, they also say that it's not undergoing rotation. And when the Sagnac type experiments or this Brilliant Hall type experiment shows that up, they don't say, well, it should have been zero because the Earth is not rotating. They say the universe is rotating around the Earth. So
they go to that extreme. The geocentrists go to the extreme that the Earth itself doesn't even rotate. Although I think experimentally, it looks like the Earth rotates at the very least. The Earth can be at the center of the universe, but it still rotates within the universe. So, but I don't know.
That would be partial geocentrism. It wouldn't be full.
If you go full geocentrism, you gotta make the Earth absolutely stationary. In which case, I think it's probably logically okay to make the entire universe rotate around the Earth to get that effect. Yeah.
By the way, one thing occurred to me just tangentially, following the discussion the other week, and related to what you've just said. If you have, say, the Earth and an object which is thrown or is let fall onto the Earth, and by Newton's laws, which I think are accepted, the object would attract the Earth very, very slightly, okay, towards it. Now, in the geocentric case where the Earth is absolutely fixed, what actually happens there? It couldn't attract the Earth because the Earth is stationary. So the whole thing would crack up. I don't know what they would say to that.
Well, I would probably say that experiment's never been performed, which is true.
Probably, yes. But they don't object to Newton's laws that all massive objects attract each other, with the force proportional to the mass and inversely proportional to the distance between them. So if you have an immovable object which is being attracted, what happens? The rest of the universe would move, I suppose they would say. It's like absolutely, and not allowing it to move. So if anything has an effect on it, you could even have a magnetic effect on between the magnetism of the Earth and a magnetic material. But the Earth is fixed. It's anchored absolutely. So what would happen is it would have to crack. It would have to blow up.
Would it? I don't know. I'm still thinking that there's always ways of looking at it. That if you make the Earth fixed in space, then yeah, you can kind of explain everything else going crazy. And there's no argument that you can make that would conclusively do it, point one way or the other. I was kind of thinking, well, let's suppose we, put put a gigantic nuclear explosion on the moon and cause that to move away, and then see what that does to the Earth's orbit, right? I don't know.
It's just that we've heard a lot of their arguments, and we're familiar with them because they're quite voluble. But I haven't ever heard them say anything about this, probably because it hasn't been raised. But it's just something occurred to me apropos our discussion the other week on two objects attracting each other and moving towards each other.
I only bring it up because these experiments do tend to point to Earth being fixed in place. Or it could be, my preferred embodiment is that the Earth has entrained its own little bubble of ether, and that's what we're dragging around. And that is why we observe the effects that we do. So I would predict that if you had the MX experiment in orbit, far away from the Earth, opposite the Earth, that satellite would detect the full orbital speed in an MMX type experiment. That would be my prediction, right? So someone should do that, except that as we discussed, no one will do that because everyone thinks that they will not get any result. That you put MMX out in space, that you will not be able to detect the motion of the satellite, right? So should be fairly clear, right?
I think Jim, who raised this question, sort of jocularly said some weeks ago that it would require private investment, and therefore let's start trying to raise the money to do this. But it probably would, because the established bodies would not undertake it, because, as I say, ostensibly they say it wouldn't give any result, but some of them actually may fear that it would, and that's another reason why they wouldn't do it.
Yeah, so we should fund a CubeSat. It's like these 5-inch satellites. You can send them up relatively inexpensively. You just have to make an MMX experiment that can fit within 5 inches, but I'm sure with modern electronics, we should be able to do that. Modern electronics and lasers, we have access to much more sophisticated devices that we can buy off the shelf than anything that those guys had, 200 years ago.
Franklin?
Yeah, go ahead, Dennis.
Oh God, I'm having a senior moment. I dropped my. Let me think just a second. I'm gonna have to come back. I slipped my mind what I was gonna say. I'm sorry.
Okay, well, we got a few other comments here. We're getting towards the end here. So Cornelius is saying that the light wave you see is not the gravity, as gravity is longitudinal and light is transverse. Okay, so he would disagree because he thinks gravity is a longitudinal wave and light is a transverse wave. So he would disagree with, say, my hypothesis that they're exactly the same. Okay. Of course, my response to that is that light is not a transverse wave. Okay, once again, I might be the only person in the universe who believes that, but I challenge all the people who do believe that light is a transverse wave to show me the experiment that shows me the actual up and down component in light, right? I remain completely unconvinced that polarization shows that light is transverse. As you can see, that is an indirect measurement of what the light could consist of. It's kind of consistent with that idea, but if light is this transverse wave of varying magnetic and electric fields, then we have things that can detect magnetic and electric fields, and you should be able to show me that as a wave travels, that you can see the magnetic field increase, magnetic field decrease. But I think we discussed this quite thoroughly in email. I think even everyone there agreed that there is no such experiment to show that light is got a transverse component in it. All right. I just argue that light travels with rays, which is very clear, like a laser beam, right? It's travels like a pencil, basically. And once you have a pencil, then you can polarize the directions of the pencil, right? The pencil, you can put it through vertical slots, and that will eliminate all the left and right, or you put the horizontal slots, that will eliminate all. So polarization happens perfectly fine. if light behaves as a ray, and that's the only thing it has to behave. It has to behave as a ray. It doesn't have any transverse components in it. So.
Well, I think I had mentioned previously that the energy density, the Poynting vector, does behave as a ray, but you can detect. Well, first of all, the transverse, what I would call the transverse electric and magnetic fields, can be varied by imposing external magnetic and electric fields, and also that's experimentally, and also theoretically they follow from Maxwell's equations if you accept those.
So Jim says if someone's got $2 million, we can launch a CubeSat. Really, it's that much still? $2 million? That's a little bit more than my pocket change. Plus, we have to have the cost of developing the actual CubeSat itself. So.
But by the way, it could be argued that we indeed should put our money where our mouths are. So in other words, if we were so convinced, all of us, that this would yield a positive result, we should put a competition out, and we should say, look, if NASA does it or anybody does it and they have a null result, we'll give them $2 million.
Now, I think there's still a chance. The thing is that we should find some experiment that is going in solar orbit, and then propose an experiment testing, say, relativity or something like that will confirm relativity, and then sneak it on that way, right? And then when they get the results, they'll go, wait a minute, this is like totally not showing speed of light constant in all frames. Oops. Well, then we're going to propose a new hypothesis, which is there's an ether and it can be playing with that, right? Okay. We have to hide it in terms of relativity, right? You have to. That's what we need to do. That would be my evil plan. It's just to on the next orbital satellite launch,
Franklin?
piggyback it on one of these other relativity experiments, right? But I'm pretty sure, like I said, the relativity experiments already use some of this MMX type stuff, and that probably the data is out there. You just have to go find it. Just any satellite in solar orbit should show this, right? And we sent plenty of those around, right?
Franklin?
Yeah, go ahead. Did you get your train of thought?
According to J.P. Wesley, there's both longitudinal radiation, electromagnetic radiation, and also transverse type electromagnetic radiation. And it could, and this is not in his book, but it could be the reason the sun looks so much bigger than it's detected to be at the old paradox is because the detectors only detect transverse radiation, not longitudinal.
Well, that could be, but I would tend to disagree with that. I mean, the problem is you got a radio antenna. All we know is that we send a radio wave. It's an oscillating signal, and we receive it in our antenna as an oscillating signal that turns into electricity, right? We don't know what happened between the transmitter and the receiver, right? And to say that that the receiver is only receive transverse versus longitudinal. I mean, I claim that it's all just like sound waves, right? Which is all, I don't know, longitudinal, I suppose. But that's kind of the problem. But we seem to have come to the end of our 2 hours here. Once again, I thank everyone for coming and participating. Just to summarize, we kind of did Winston Mailbox today and started to discuss this idea that it is there's a gas in between space, and that's what's carrying the electromagnetic waves. We discussed various reasons why that isn't true. I don't think anyone in this particular forum would agree with that. There's a number of reasons why that couldn't be. But then we got into, well, if it's not gas, then what is it? What is the medium? So it could have been Alistair's fundamental particle, could be something we can't detect, could be a neutron seed. So that's my personal favorite, and I gave some reasons why. We discussed why it could or could not be a neutron seed. Why doesn't this all disappear in 15 minutes and that sort of thing. And then we just kind of went down to, detecting, questions about detecting if it's entrained or not. And if anyone's got $2 million, send it my way. We're going to send up a CubeSat to go send a satellite around solar orbit and see whether the MMX can detect the speed of the orbiting satellite that way. So Jim suggests crowdfunding. Okay. Okay, Jim, I'm going to put you in charge of that. Give me my $2 million next week, and we'll start working on that. Okay. All right, but that will do it for this week's episode, and hope to see you next week.